What's up, everybody? This is Matt Brown. Today we're taking yet another look at the Mojo C-75 Wi-Fi router. Today we're going to be looking at the network traffic. We obtained a root shell in the last video, so if you haven't seen that video, definitely go check it out. But now we have a root shell. We want to understand what type of network traffic is coming out, is emanating from this Wi-Fi router out to the internet. So let's go over to my screen and take a look at that. So like I said, we do have a root shell here. I'm not going to log in quite yet because I do notice that there's some kind of a watchdog that if you leave the shell open for long enough, it like reboots the system. So we're not going to log in quite yet. First, what I'm going to do is I'm going to describe the setup that I use to monitor network traffic from IoT devices. So over on the desk, I have the Ethernet port of this Wi-Fi router plugged in to a USB Ethernet adapter that is connected to my machine. So this is a GitHub repository that I've talked about in the past. I will post it in the description of this video as well. This is how I do, this is my general approach to monitoring IoT devices and to examining their network traffic. So we can ignore all the stuff about Wi-Fi for this example because that's not applicable. But here is that Ethernet interface that's connected via USB, and it is connected to a bridge. In Linux, a bridge is just a way to really meld together two interfaces so that they can both operate as one, and the reason for that is really just because I have Wi-Fi and Ethernet here. But that bridge interface runs a DHCP server, so it's going to hand out an IP address to my IoT device. And so if that IoT device is configured, like most of them are, to use DHCP, it will get an IP. Then I have a whole bunch of magic IP tables rules that are going to connect that LAN, that one network, to the upstream network, which you could think of as like the internet, but in my network, it's just onto my general test network for IoT devices. And then I have these optional IP tables rules also that can redirect traffic to some kind of a proxy that I can then use to examine that network traffic. So what we're going to do is we're going to go over here and just really quick go over my script. So I can close out of that and look at my script. So I'm just going to focus on one thing right now. So here are those IP tables rules that set up all the routing. So they're going to allow traffic to be forwarded between the bridge, that LAN interface, and the internet, that WAN interface. And then right now I have this rule commented out. So right now all I'm going to do is I'm going to be passively monitoring network traffic. When I come back, I'm going to redo this and uncomment this rule so that we can start intercepting and attempting to do a SSL TLS man in the middle on some traffic, and we're going to see what happens. So for right now, we're going to run this, and then over here, we're going to restart our network capture, and it's going to say that there's no interface because when I run my little router script, it deletes and recreates the bridge interface. So sometimes you have to restart Wireshark to get this to work. All right, so we are seeing network traffic right away coming from this device. And it's really, okay, here we go. This is awesome. So we're seeing some UDP traffic, which is pretty interesting. And then here we are seeing kind of what I was referring to. We are seeing some traffic that is encrypted with TLS. And so all we can see of the TLS communications is we can see the client hello, and then we can see the server hello. And the server hello can sometimes be really helpful because we can look inside the certificate to see what server it's communicating with, right? So inside the server hello, we can dig into this handshake message, and then we can go find okay, anyway, we're gonna ignore that for now. But you can see here in the hex dump, it says ccbcloudwifi.com. Like, okay, that's kind of interesting, right? So one thing I was doing is I was looking through my newly obtained root shell to see if I could get a hint at what binaries on the system were running things, we're reaching out to systems out in the internet, right? So we're going to log in with root because we changed that password hash. And so the first thing I tried to do was netstat dash this with a P flag, and it is busy boxes, so it doesn't let me do that. So so it's unfortunate because I can't get like the name of the program that is doing any communications, right? But if I tell it to, okay, let's do like UDP traffic. So here you can see some, UDP stuff listening. Display all sockets. Let's try to display all sockets. All right. There is something listening. We do have SSH listening, which is very fascinating on this system. So, okay, I'm not actually seeing what I want to see here. But I really had a dead end here in Netcat. But then what I'll resort to is just using PS to look at what processes are here. And most of these processes I recognize. So DH client. There's this link monitor program. There's some shell script running. And then there's this sensor D Linux, which I don't recognize, right? So the first thing I did, and we can see even the path that it's running out of. And it's running out of that OPT partition, that is housed on that second flash chip. So I'm just going to copy that. And I'm going to go over to my shell here where we did our firmware mod, and this is that unpacked file system, right? So I'm just going to say find grep for that file. Oh, here's that binary. So we have a copy of this binary already. So we can run file on this program, and we can see that it is a MIPS executable program. And so one thing I like to do, like the first thing I do, even before I like pop one of these programs into Ghidra and start doing really deep reverse engineering, is just run strings on it. You'll be amazed what you can find by just looking at the strings inside of a program. And I'll usually pipe it into less, and I'll just keep hitting page down until I get past like the executable code part of the strings, and I get to the actual interesting stuff. Okay, there it is. Let me go back up. Okay, so here we can definitely see this is like the beginning of the code, and okay, there's some really interesting stuff here. It's talking about like a download server and stuff like this, and so I'm going to assume it's trying to parse that from this little comp file. So there's this configuration file, there's another one here. So these configuration files are going to be very interesting for us to look at. So I'm actually going to copy that and go back to my live root shell that I have, and I'm going to cat that file out. And so what I find in there is, so that other thing I was referring to, there's like, some kind of another server. Oh, this, server host name, it's blank, but there is a host name here under primary server. Okay, that's pretty interesting because that might be a system that this device is kind of hard-coded or designed to reach out to, right? Okay, we got redirector.online, spectraguard.net. Super interesting. Let's copy that, and let's go back over to Wireshark. So a cool thing that you can do in Wireshark is that if you just want to do like a raw, like kind of strings search through something, you can actually just say IP contains, and then you can search for a string. So we don't get back anything from that. That is super interesting, and I'm gonna guess that is because we didn't capture the full boot of this device. So So what I'm going to do is I'm going to cheat instead of making you sit through an entire reboot of the system. So I'm going to ping, which should initiate a DNS request. Oh wow, it's not getting that. Fascinating. What do we got here for DNS, guys? Oh, interesting. That maybe that contains command was just not working correctly. Because here we see that file we were looking for, right? Redirector online, SpectraGuard. Yeah, right here we see we see the DNS lookup. I don't know why we didn't see it in our filter. IP contains. Okay, let's just do redirector. Let's just say IP contains that. Okay, well that filter worked. It must be the dots. It must actually be some like, it must think it's like regex or something. So, so there we go. We can search through and we can find these DNS requests. So one thing, if I find a DNS request, usually after the DNS request, after the lookup happens, then something else is going to like some kind of network flow is going to happen after that, right? So if I want to look at, let's just say, let's do this one, because I'm pretty sure this was generated from my ping command. So what I'll do is I will mark that packet, and then I will completely remove the filter, and then we can see that immediately following this DNS request, this UDP traffic starts to happen. So that's really interesting. And what's even more interesting is when we actually dig into this UDP traffic, we see that it's just this raw kind of binary protocol. It doesn't identify it as any like known protocol. Wireshark doesn't. But we see this is the data blob that the device is sending out to the internet, and it's not encrypted. And how do I know this is not encrypted data? Most of it's just a bunch of zeros. But there's something really interesting down here. 30 B6 2D 50 3B BF. I recognize that because that is the MAC address of the device. So the device is reaching out to some server, and the MAC address actually appears twice. So it appears right up at the beginning. Yeah, right here. Yeah, we can see up there and down at the bottom of this UDP binary protocol. It is transmitting its MAC address out to some server on the internet. And that's obviously not encrypted, right? So, okay, so right now it's not too sensitive, this data, but what is interesting, it doesn't seem like there's any real form of authentication that I can see that this protocol is going to be performing when it sends this request, right? And it does get this response, which is also a very, very interesting response, right? Because then we see these other like DNS requests to a slightly different redirector, right? This redirector.ccb.cloudwifi.com. And so we can actually see that in this raw protocol of the UDP response. So we can see it's almost like it's saying like, hey, go to this other system and go talk to it, right? And it does, and it goes and does the same thing to this other redirector, whatever a redirector is in this protocol. I don't know, but it sends a very similar message to that one, this UDP protocol. Same byte length and everything, 84 bytes that it's sending. This would be a really cool protocol to reverse engineer, try to see like how is it working? Can you learn any other types of messages that this protocol supports? That would be super interesting. But the next thing I am also interested in is this encrypted traffic here. So we're seeing all of this, these TLS communications, and so I always want to see what's going on inside of a TLS communication, right? And so what we're going to do is we're now going to go and make that modification to our man-in-the-middle router script. And I'm going to uncomment this IP tables rule. So what this IP tables rule is doing is it's saying any traffic on the bridge that's coming from the bridge interface, right? That's coming from the LAN side of my man-in-the-middle setup, and that has a destination port of 443 that's going out to port 443, redirect it to port 8081. And kind of implied in this, it said it's going to redirect it locally to whatever the IP on this interface is. So what we're going to do is we're going to save that script, and then we're going to run this again. Yeah, Wireshark's going to tell me, it's going to complain because in that script I'm tearing down and rebuilding that bridge interface. And then what we're going to do is we're actually going to use a program called sslsplit. The reason for this is because man-in-the-middle proxy seems to not support the super old ciphers that whatever this domain is using supports. I think there's supposed to be a way in man-in-the-middle proxy where you can say like support SSL v3, right? But something's not working right. It might be like the underlying OpenSSL library I have installed, but sslsplit is like, sure, I'll use whatever terribly old crypto that this server wants to use. And so again, we're running this proxy on port 8081, and we're just running it on all interfaces because if you put localhost, it actually won't work. It's actually going to send it. That redirect is going to happen to the IP on the bridge interface that I have set up. So we are going to run this sslsplit command, and it's using for the key insert that it's going to use to generate these fake certificates. It's going to fake whatever certificate that it sees on the server side of these communications. It's going to sign those with the man-in-the-middle proxy certificate. I have not made any modifications to the firmware such that it would trust this CA that I have. And so we're going to see if we can successfully demonstrate a lack of SSL certificate verification. So I'm running my program here. We're already getting, okay, we're already getting connections. So I am going to just run, sometimes those connections fail, is what I experienced before. So I want to observe the traffic from this side of watching it over the network. Okay, there we go. And so that means, so me seeing that, I know that I've got good data from sslsplit. Because what I should see, if things are working properly on this device and it's not vulnerable to a man-in-the-middle attack, is you should see client hello, so the server should say hello and send its certificate, and then the client should just like terminate the connection because it would be receiving a certificate from the server that it does not trust. But it seems that when it's connecting to this system, it is not performing any kind of certificate verification. So we can see the traffic inside of that those TLS communications. So I'm going to close out of sslsplit. So now I have this PCAP right here, which I'm just going to open in another Wireshark session. And so here we have, okay, so sslsplit, it's kind of, it on the fly makes a synthetic PCAP. These are not exactly the bytes as they cross the network. It creates what it appears to be like a raw TCP connection, but and then this is a complete false positive from Wireshark. It's saying that, you know, it's using TLS. It's not using TLS at all. The only reason why Wireshark is like false positive detecting that this packet is SSL is because how it does that is, again, destination port 443. That's why it thinks it's TLS, TLS or SSL, but it is not. If we actually look at this data, so here we see a SYN-ACK, ACK. If you're not familiar with TCP, that's like a handshake agreement to start a session where two hosts can communicate with each other. So there's no interesting data in there. That's just the initialization of the communications. And then we see this. Again, it's saying it's SSL, but this is not SSL. This is the decrypted data. And so it's not going to identify it at all in here. We have to look at the raw data here. And you will notice that it looks very familiar to something we just looked at. So here again in it is 30, B6, 2D, 50, 3B, BF. this is that same exact raw binary protocol, which is really interesting because it has like a UDP version of the protocol that's completely unencrypted. And then it has this other version of the protocol that uses TLS, but it's not doing certificate verification. That is, it is encrypted, right? If you were just if you were just able to passively observe the network traffic, but were not able to do this active man in the middle, then you would not be able to read this data. You have to be a active man in the middle to perform this attack. But it's really fascinating that they are not performing any certificate verification. And I had a hunch when I was looking through the firmware that this was the case, because I was grepping and I was looking through the firmware and I couldn't find any SSL certificates, which is like there should be there should be root SSL certificates that are a root of trust for the device making outbound TLS communications to the internet. Which wasn't the case. So we found a little bit of a vulnerability. Again, it's what is the data that's vulnerable to this man-in-the-middle attack? Well, it's data that they send in the clear over UDP anyway, so not really a big deal, but this is an example of how you would exploit a device's not performing certificate verification. And I have found instances of that in other devices where, credentials are traversing that TLS session, and account takeover is almost always possible when that's the case. So, thank you for watching this video. I hope you learned something, and have a good day.